Hi there, my name is Andrew Keat, and today I'm going to talk about how global warming is contributing towards ozone depletion. So first of all, 90% of ozone resides in the stratosphere. It absorbs hazardous UV radiation from the sun, and without the ozone, the Earth's surface would become entirely sterile from the UV radiation. And as we know, there are three types of UV radiation: UVA, UVB, UVC, of which the most hazardous is UVC, but is entirely absorbed by ozone in the upper atmosphere. UVB being the second most harmful, as it can cause direct DNA mutation, which is partially absorbed by the ozone, and then UVA, which can cause indirect DNA mutation. The ozone hole refers to the depletion of the protective ozone layer in the upper atmosphere over the Earth's polar regions. So now some of the major sources of ozone depletion. Ozone is depleted when it reacts with molecules containing nitrogen, hydrogen, chlorine, and bromine. Around the 1970s, CFCs were a major issue as they were abundantly released into the atmosphere and caused the ozone layer to deplete significantly. As a result of this, in 1989, countries all around the world decided that they wanted to gradually phase out the use of these potent ozone layer depleting chemicals. However, the problem with these chemicals was that they had such a long lifetime that we were seeing the effects of ozone depletion, obviously even now, and long after the Montreal Protocol was enacted. As you can see from this short video, it will show the ozone hole over Antarctica from before the Montreal Protocol. And so at that point, early on, the ozone hole wasn't even that large, but as we go further on, past the Montreal Protocol in 1989, we can see that the ozone hole is still getting bigger as these chemicals are still around in the atmosphere, as they have such a long lifetime. So how is it that global warming may be contributing to ozone depletion? I think it must be said that global warming is not the main cause of ozone depletion, and likewise, although ozone is a greenhouse gas, it is not the main cause of global warming. But as we know, it is pretty undeniable science at this point that rise in temperature from 1960 until present day directly correlates with CO2, the rise in CO2 emissions over the same time period. So by the nature of CO2 being a greenhouse gas, it traps heat into the lower troposphere, the lower atmosphere. And as a result of this, we actually get a cooling effect in the upper atmosphere, namely the lower stratosphere. And like I say, these heat-trapping gases such as CO2 contribute to the cooling of the upper atmosphere, causing increased ozone depletion, particularly in the polar regions. In the Antarctic, when there is no sunlight, heterogeneous reactions happen on the surface of polar stratospheric clouds, creating CO2 gas. In the springtime, when sunlight breaks the CO2 gas into Cl molecules, it is then that these Cl molecules deplete the ozone, react with the ozone, and therefore deplete the ozone levels. And what we are seeing, by the nature of the cooling happening in the upper atmosphere, we're seeing that these polar stratospheric clouds are staying around for longer, and therefore this allows for more reactions to take place on the surface, creating more Cl2, therefore creating more Cl molecules when the sun eventually breaks it down, and increasing the level of ozone depletion that we have in the polar regions. Evidence of this can be seen over the Arctic, which typically doesn't have an ozone hole. As we can see here, on the left in March 2010 is a more typical picture of the ozone levels, ozone concentration over the Arctic. But in 2011, we can see that the blue means that the ozone levels have been significantly depleted, and this is evidence of the stratospheric cooling causing more ozone depletion. Thank you very much for listening.